Hello, and welcome to this video about box and whisker plots. Today, we'll learn how to interpret box and whisker plots to answer questions about data. We'll also discuss when to display data with a box and whisker plot. Before we get started, let's review a few things. First, a dataset is a collection of numbers that relate to a specific topic. For instance, class scores on a math test are a dataset. Mathematicians use graphs to illustrate datasets. A box and whisker plot, also called a box plot, is a type of graph that displays quantitative data. The graph of a box and whisker plot involves plotting 5 data values. These values are called the 5-number summary of a set of data when ordered from least to greatest. The data values are the minimum or lowest number in the dataset, the lower quartile, called Q1, which is the median of the first half of the dataset, the median, which is the dataset's middle value, the upper quartile, called Q3, which is the median of the second half of the dataset, and the maximum, which is the highest number in the dataset. When graphed, a box and whisker plot looks like a rectangular box with a vertical line going through it. The box is drawn from Q1 to Q3, and the vertical line intersecting it represents the median of the dataset. The box has 2 horizontal lines called whiskers on either side of it, extending to the maximum and minimum values in the dataset. Let's look at an example of a box and whisker plot together. Using the number line below the box and whisker plot, let's identify the 5-number summary of this dataset. The minimum is the lowest number in the dataset. This data point is the furthest to the left. It's connected to the box by a whisker. In this case, the minimum is 7. The maximum is the highest number in the dataset. The data point is the furthest to the right. It's also connected to the box by a whisker. In this case, the maximum is 19. Next, let's identify the median. The median is shown as a vertical line inside the box. In this case, the line intersects the box between 11 and 12. Therefore, the median is 11.5. From here, we can identify the lower and upper quartiles. The lower quartile Q1 is shown as a vertical line forming the left side of the box. In this case, the lower quartile is 9. The upper quartile Q3 is shown as a vertical line forming the right side of the box. In this case, the upper quartile is equal to 14. So to summarize, our minimum is equal to 7, our lower quartile, or Q1, is equal to 9, our median is equal to 11.5, our upper quartile, or Q3, is equal to 14, and our maximum is equal to 19. Now that we know how to interpret a box and whisker plot, let's look at a data set to use those numbers to create our own. Consider the following data set. Before we can create a box and whisker plot, we have to put our numbers in order from least to greatest. Now that the numbers are in order, we can identify the 5-number summary. Let's start with the minimum and maximum. The minimum is 5 because that is the lowest number in our dataset. Likewise, the maximum is 20 because that is the highest number in our dataset. Next, identify the median. Recall that the median is the middle value in a list of numbers ordered from least to greatest. In this dataset, the median is 18. From here, identify the lower quartile and upper quartile. To identify the lower quartile, examine the data values to the left of the median, 5, 6, and 8. The lower quartile is the middle value of this portion of the dataset. In this case, the middle value of 5, 6, and 8 is 6. Therefore, the lower quartile is 6. To identify the upper quartile, examine the data values to the right of the median, 18, 20, and 20. The upper quartile is the middle value of this portion of the dataset. In this case, the middle value of 18, 20, and 20 is 20. Therefore, the upper quartile is 20. So to summarize, our minimum is equal to 5. Our lower quartile, Q1, is equal to 6. Our median is equal to 18. Our upper quartile, or Q3, is equal to 20. And our maximum is equal to 20. Now that we have the 5-number summary, we can create a box and whisker plot. On a number line, draw small vertical lines above each of these numbers, 5, 6, 18, and 20. Next, construct the box portion of the box and whisker plot. Draw a rectangle from the Q1 value at 6 to the Q3 value at 20. From here, draw the vertical line at 18 to represent the median. Last, draw the whiskers extending to the minimum and maximum values, drawing one horizontal line extending from the left of the box to the minimum, which is 5. Note that the maximum is 20, which is the same as the upper quartile. Since this value is already part of the graph, we do not need to draw a whisker extending to the right. The interquartile range, or the IQR, is the width of the box in a box and whisker plot. In other words, it's the difference between the upper and lower quartiles. In this example we just looked at, the upper quartile was 20 and the lower quartile was 6. Since 20 minus 6 equals 14, the IQR for this set of data is 14. Sometimes data sets include outliers. An outlier is a data point that lies outside most of the other values in a dataset. If a number is significantly greater than or less than the rest of the numbers in the dataset, it's probably an outlier. The 1.5 IQR rule determines whether a number is an outlier. If a data point is less than Q1 minus 1.5 times the IQR, then it is an outlier to the left of the box and whisker plot. Likewise, if a data point is greater than Q3 plus 1.5 times the IQR, then it is an outlier to the right. Let's look at an example of a dataset with an outlier. Consider the following dataset. Let's find the 5-number summary, looking for outliers, and create a box and whisker plot. First, order the numbers in the dataset from least to greatest. Now that the numbers are in order, we can identify the 5-number summary. Let's start with the minimum and maximum. The minimum is 70 because that's the lowest number in our dataset. Likewise, the maximum is 100 because it is the highest number in our dataset. Next, identify the median. Recall that the median is the middle value in a list of numbers ordered from least to greatest. Since this list has an even number of data, there are 2 data points in the center, 79 and 82. To identify the median, add these numbers together and divide them by 2. 79 plus 82 equals 161, and 161 divided by 2 equals 80.5. Therefore, the median is 80.5. From here, identify the lower quartile and upper quartile. Let's start with the lower quartile. To identify this number, examine the data values to the left of the median, which is 80.5. These numbers are 70, 72, 74, 78, and 79. The lower quartile is the middle value of this portion of the dataset. In this case, the middle value is 74, so the lower quartile is 74. To identify the upper quartile, examine the data values to the right of the median. These numbers are 82, 84, 84, 86, and 100. The upper quartile is the middle value of this portion of the dataset. In this case, the middle value is 84, so the upper quartile is 84. So to summarize, our minimum is 70, our lower quartile, or Q1, is 74, our median is 80.5, our upper quartile, Q3, is 84, and our maximum is 100. Next, we want to find the interquartile range. We can use the IQR to look for outliers in the dataset. The IQR is the upper quartile minus the lower quartile. Q3 minus Q1 equals 84 minus 74, which equals 10. Therefore, the IQR is equal to 10. From here, apply the 1.5 IQR rule to see if there are any outliers. According to the 1.5 IQR rule, any data values that are less than 59 or greater than 99 are considered outliers. Therefore, 100 is an outlier on our dataset. On a box and whisker plot, outliers are usually shown as separate points. Separating 100 from the dataset, the maximum is the next highest number that is not an outlier. In this dataset, that number is 86. On a number line, draw small vertical lines above each number in the 5-number summary. 70, 74, 80.5, 84, and 86. Additionally, draw a point as an open circle at the outlier 100. Next, construct the box portion of the box and whisker plot. Draw a rectangle from the Q1 value at 74 to the Q3 value at 84. Last, draw the whiskers extending to the minimum and maximum values. Draw one horizontal line extending from the left of the box to the minimum, which is 70. Draw another horizontal line extending from the right of the box to the maximum, which is 86. Box and whisker plots are useful ways to display quantitative data because they're easy to read. Additionally, they split the data into chunks of 25%. A box and whisker plot shows the shape of the distribution, its variability, and its central value. For these reasons, researchers and mathematicians use them to visually summarize quantitative data. Let's consider a scenario and interpret a box and whisker plot to answer some questions about the data. A cross-country team kept track of how many miles each team member ran per week. The data is displayed in the box and whisker plot. The 5-number summary of the data is the minimum is equal to 15, the lower quartile or Q1 is equal to 33, the median is equal to 41.5, the upper quartile is equal to 48, and the maximum is equal to 56. The graph also shows one outlier, which is 8. Given this information, answer the following questions. What is the greatest amount run by one team member during the week? The greatest amount of miles run is the maximum. Since the maximum in this dataset is 56, the greatest amount run by one team member during the week is 56 miles. What percentage of team members ran between 33 and 48 miles during the week? 50% of the team members ran between 33 and 48 miles during the week. Each quartile includes approximately 25% of the data in the dataset. Therefore, the lower and upper quartiles together contain approximately 50% of the data in the dataset. Are there any injured team members? If so, how many miles did he or she run during the week? Injured team members run significantly fewer miles than the majority of the team. There is one injured team member, represented by the outlier. This team member ran 8 miles during the week. I hope this video about box and whisker plots was helpful. Thanks for watching and happy studying.